So I have a sequence here, and I want to determine if this converges, and if it does, to what value. All right, so to do that, I have to take a look at a limit, right? I have to take the limit of a sub n, or that expression that a sub n equals, as n goes to infinity. Now, to do this, I'm going to define a function. I'm going to let f of x equal x squared plus 1 over x squared to the x power. Now that I've done that, a sub n is equal to f of n. So applying the theorem that we talked about in the lecture, the limit of the sequence as n goes to infinity is equal to the limit of my function x squared plus 1 over x squared to the x as x goes to infinity. Now, if you think about what happens to that expression inside, as x goes to infinity, x squared plus 1 over x squared goes to 1, right? So this expression here is 1 to infinity. And this is a form that we can turn into L'Hopital's, into an indeterminate form where we can apply L'Hopital's rule. Right, so to do that, I'm going to look at the limit as x goes to infinity of the log of x squared plus 1 over x squared to the x. And I'm going to undo that. Remember how this process works when we talked about L'Hopital's rule. I'm going to undo that at the very end by taking e to whatever the limit of the logarithm becomes. So if we bring the x outside, this is the limit as x goes to infinity of x times the logarithm of x squared plus 1 over x squared. All right, now as x goes to infinity, this is going to become infinity times the log of 1, which is 0. All right, so I can make this into an indeterminate form by rewriting it as the limit as x goes to infinity of the log of x squared plus 1 over x squared over 1 over x. Right now, this is 0 over 0. That is an indeterminate form. So L'Hopital's rule applies. And if I differentiate the numerator, and I will, it's the chain rule. I couldn't remember the name. It's the chain rule and the product rule, and it gets a little messy. You're welcome to walk through all of those steps. Right? If you do, this becomes the limit as x approaches infinity of negative 2 over n. Excuse me, it's x is here, right? X times x squared plus 1 divided by negative 1 over x squared, which is the limit as x goes to infinity. The negative signs cancel here, so this will be 2x squared over x cubed plus x. We know what that limit is. It's a rational expression. The degree of the denominator is bigger than the degree of the numerator, so this is going to be 0. Right? Now I still have to undo this logarithm part that I did over here. Right? So my answer is going to be e to the 0, which is 1. That's what the original sequence converges to. So if you'd like to get the full context, you can click on the link here to see the lecture I was referring to. And if you like this example or found it helpful, please go ahead and click on the like button down below.